We are going to be looking at the maximum likelihood estimate for an exponential distribution. Exponential distribution is a continuous distribution. Now, suppose we have a set of random variables, says x1, x2, x3, xn. And all these random variables, they are independent, identical distribution. They are independent, identical distribution. Then the PDF of this exponential is given us, that is the PDF of the exponential distribution is given as f of x, comma, theta equals to theta exponential minus theta x, whereby our theta is a parameter, is the only parameter in an exponential distribution. And we should also know that x is not a negative value. X cannot assume any negative value. That means x is greater than 7. 1, 2, 3, but x cannot be negative value. Now, try to look for the maximum likelihood estimate. The estimate is the maximum likelihood of the distribution. The first step, which is step 1, we're going to take the maximum likelihood. Take the likelihood of this distribution. Likelihood of the distribution. So we check the likelihood, and doing that we have all s comma theta equals to s plus 1 to n theta exponential raised to power minus theta x. And what this implies is that the likelihood what implies that this is going to give us theta raised to power n exponential minus theta summation x. We take the likelihood of the distribution. Now step 2. On this step 2, what we're going to do is to take the natural log. So take the natural log. So for us to take the natural log, we need to have mean the likelihood x theta equals to mean theta raised to power n plus mean exponential raised to power minus theta x. And this is going to give us, we can write it on the smart, that is n should come back to this place. We have n mean theta minus and plus will give us minus, so we have minus theta summation x, generally summation x right from here, theta summation x ln exponential. Now if you look at this together, we have n theta minus theta summation x ln exponential. Ln is the inverse of exponential, exponential is the inverse of ln. Therefore, this 2 is going to be what? Is going to be 1. And therefore, this step becomes L in theta minus theta summation x. Now, the next step is step 3. Find the derivative with respect to the parameter, which is the theta. So we differentiate this with respect to theta, and this will give us the mean x comma theta divided by the theta equals to, by the time we take the derivative of this, we need to have n divided by 5 minus, with respect to this is going to give us summation x. So n over theta minus summation x. Now, step 4, equate this equation to 0. So this is going to give us n over theta minus summation x equals to 0. And from this case, we can have um, n over theta equals to summation x. And the last step, which is step 5, solve for the parameter. Solve for the parameter. And we solve for the parameter. Right from here, we can just have n equals to theta summation x, making this the summation of the formula. This will give us theta cap equals to n divided by summation x. This is the maximum likelihood estimate of exponential distribution. We can write this in another form. This is the estimate, but we can also write it in another form, having theta cap equals to 1 over x bar, or we can also write it in this format, theta cap inverse equals to x bar. All this one are just the twist of these the estimates of the maximum likely estimate of an exponential distribution. So thank you for watching.